Before moving to the lesson, I am going to ask you a question. Right. I'm going to ask you a question. The question is this. You are going to you are going to buy a bicycle. Right. Here, then you have two conditions. The first condition is it must be less than 25,000. Right. And it must be a blue color one. Right. My first question is, if you are going to consider these two conditions, right? That means if you are going to buy, definitely the bike must be less than 25,000 and it must be blue color. What kind of logic gate is suitable to suitable for taking the decision or represent the condition? Type it. බයිසිකලයක් ගන්න හදන එක conditions දෙකක් තියෙනවා 25000ට වැඩි අඩු වෙන්න ඕනේ blue color වෙන්න ඕනේ ඔයාට මේ conditions දෙකම satisfy වෙන්න ඕනේ මේක ගන්න නම් මේ conditions ටික පෙන්නන මේ කියන්නේ ඔයාට මේ දෙකම satisfy වුණොත් විතරයි ඔයා මේක ගන්නෙ එතකොට මේක represent කරන්න මීට සමානව සමපාතිකව තියෙන conditions පෙන්නන logic gate එක මොකක්ද? Which logic gates represent the condition what you are seeking? I have got one answer. Okay, now I am my question is, right, if either of condition, one condition is true from these two conditions, I am going to buy this bike. If both conditions are false, I am not going to buy. එක condition එකක් හරි තියෙනවා නේ 25000ට අඩු නම් එහෙම නැත්නම් blue color නම් මම මේක ගන්නවා. එහෙනම් මොන gate එකද? Right. Yes, definitely it's OR gate. Because if you refer to the OR gate truth table, right? My question, according to my question, condition 1 is here, condition 2 is here, 1 is less than 25,000, the second condition is blue color, right? Here first combination 0 0, that means it's not less than 25,000, not blue color, I am not going to buy it. In here it's not less than 25,000, but it's blue color. මට මේ condition එකෙන් එකක් තිබ්බා නම් ඇතිනේ මම එක ගන්නවා, right? මෙතන ඊළඟ combination එකේදී මෙයා 25000ට අඩුයි හැබැයි blue color නෙමෙයි කමන්නේ ඒක condition එකක් true, right? මම ගන්නවා මේකෙදි conditions දෙකම true, then I am going to buy. This kind of pattern is there, right, in OR gate, right? So then next question. Right, these days you know the political conditions, right? So හිතන්න ඡන්දයක් එන්න තියෙනවා. දැන් මේ ඡන්දෙදී ඔයාගේ තියෙනවා condition එකක්. You are going to cast your vote only, right? Then there are two things, right? Gotabaya Rajapaksa is there. If he is there, the condition is 1. If he is not there, condition is 0. Mahinda Rajapaksa is there. If he is there, condition 1, right? If it's not there in the election, condition is 0, right? Your choice is this. Both these politicians cannot be there in the election, but one of them must also be there, right? මේ දෙන්නම ඉන්නත් බෑ. ඒ වගේම දෙන්නම නැති වෙන්නත් බෑ. ඉලෙක්ෂන් එකට කවුරු හරි එක්කෙනෙක් ඉල්ලන්න ඕනේ. ඉලෙක්ෂන් එකට එහෙම වුණොත් තමයි ඔයා ඡන්දෙ දෙන්නේ. හැබැයි දෙන්නම ඉල්ලුවේ නැත්නම් ඒ ඡන්දෙ දෙන්නෙත් නැහැ. දෙන්නම එකට ඉල්ලුවොත් ඒ ඡන්දෙ දෙන්නෙත් නැහැ. මේ දෙන්නගෙන් එක්කෙනෙක් හිටියොත් විතරයි ඔයා ඡන්දෙ දෙන්නේ. So which gate is representing that kind of a condition? You are not going to cast your vote if both are there in the election, and you are not going to cast the vote if both are not there in the election. You are going to cast the vote only one person. From these two, only one person is there in the election. Casting vote. My casting vote, right? Whether I am going to cast the vote or not, 1 or 0, right? It depends on according to my choice. My choice is if both are not there, I am not going to cast the vote. Then condition is false. If one of them are there in the election only, I am going to cast the vote, and if both of them are there in the election, I am not going to cast the vote. එහෙනම් මේකේ දෙන්නම ඉන්නවා. මේ මෙතන මුලින් දෙන්නම නැත්තම් ඉලෙක්ෂන් එකට මම ඡන්දෙ දෙන්නේ නැහැ. දෙන්නම එකට ඉල්ලුවොත් ඒත් මම ඡන්දෙ දෙන්නේ නැහැ. දෙන්නගෙන් එක්කෙනෙක් ඉල්ලුවොත් විතරයි ඡන්දෙ දෙන්නේ. එහෙනම් මෙතනට true true, right? මේ වගේ pattern එකක් තියෙන්නේ මොකේද ළමයි? logic gates වලින් එහෙමනම් exclusive or gate වල, right? So now you know, by seeing the pattern, right, you can select the corresponding logic gate. Okay, then come back to the lesson. We learned the logic gates, right? Introduction to the logic gates, basic things are there even in this presentation. So I am not going to talk about them, right? These are the types of logic gates. And exclusive NOR gate is not there, it must be there. Yeah, we know, right? When describing the logic gates, right, we can use these three. One is Boolean expression, the other one is logic diagrams, and the other one is truth table. Right, this is the logic diagram of NOT gate. This is the Boolean expression, right? And this is the truth table. අපි හැමතිස්සෙම ළමයි මේකේ බලන්නේ A B කියලාම තියෙන්න ඕනේ නැහැ. සමහරක් වෙලාවට මේ ලෙටර් එක මොකක් වුණත් ප්‍රශ්නයක් නැහැ. right? output එකට B කියලා දෙන්න ඕනේ නැහැ, C කියලාම දෙන්න ඕනේ නැහැ. මෙතන X කියලා තියෙන්නේ. Then AND gate, right? Here the truth table for the AND gate. Now you know, on the output becomes 1 only both inputs are true, or both inputs are 1. Then the OR gate, you know, right? Output becomes 1 when one input is true or both inputs are true. Exclusive OR gate, right? Output becomes 1. Inputs have different conditions or different states. ඊට පස්සේ ඔයගොල්ලෝ දන්නවා NAND gate එක, NOR gate එක, ඒ ටිකක් දන්නවා. Then gates with more inputs, right? In previous slide, in previous lesson, we talk about the 3 input AND gate. Can you remember that when we want to get 3 conditions? For example, when you are going to select a bride, right? And then through a marriage proposal, first you use 2 input AND gate because you had 2 conditions. The girl must be fair and girl must have a dowry. Then after that, you had another condition. Girl must have a long hair. Then we use 3 input AND gate. AND gate. එතකොට මේ වගේ 3 inputs වුණොත් එහෙම truth table එක ලියන්නේ මේ විදියට. Right. Let's say students, what would happen if there are 4 inputs, right? When you have this kind of a 1, 2, 3, 4, how many combinations are there if you have 4 inputs, right? One input has 2 states, either 1 or 0. Then how many combinations are there? Then if you have 4 inputs, how you can calculate, right? One input can have 2 conditions, then another input, it can have another 2 conditions, then the third input, it can have 2 states or 2 conditions, and the fourth input can have 2 conditions. So therefore altogether 2 times 2 times 2 times 2, right? 4, 8 and 16. Then the 16 combinations are there if you use a 4 input AND gate. 3 inputs නම් කොහමද ඒක හොයන්නේ? 3ක් නම් 2 වැඩි කිරීම 2 වැඩි කිරීම 2. හැමතිස්සෙම ළමයි මේක හොයන්නේ exponent එකට දාන්න number of inputs. If you have 2 inputs, how can you find the different combinations, right? You can find the different number of different combinations you can find by using 2 to power exponent. If you are going to use 2 input logic gate, right, then exponent is 2. 2 to power 2 equals 4. 4 combinations will be there in the truth table: 0, 1, 0, 1, 0, 0, 1, 1. If you use 3 input AND gate, right? So the exponent is 3 now. 2 to power 3 equals 2 times 2 times 2. 8 combinations, different type of combinations will be there. Then how you can write them? First row 0, 1, 0, 1, 0, 1, 0, 1, then 0, 0, 1, 1, 0, 0, 1, 1. Third row, you are going to change after 4 digits: 0, 0, 0, 0, 1, 1, 1, 1. මේ විදියට. හරි. හදිස්සියවත් 4 තිබ්බොත් 4ක් තිබ්බොත් කොහොමද වෙන්නේ? exponent එක එන 4 වෙනවා, 2 to power 4, right? Equals 16. 16 different combinations will be there. එහෙනම් ඔයගොල්ලෝ දන්නවා inputs ගාන බලලා ඉවරලා කොච්චර combinations තියෙනවද කියලා හොයාගන්න එක. Right, now you are going to learn about this combinational circuits. Gates are combined into circuits by using the output of one gate as the input for another gate. Right, so the combination in combination circuits, you can see here, this is a 1 gate, this is a, actually this is a AND gate is here, right? Output of this AND gate is D. Then this AND gate, output of this AND gate is E, right? In here, output from these 2 AND gates have been used as the input for this OR gate. මේ බලන්න. මේ ඉස්සෙල්ලා logic gates දෙකෙන් ආපු AND gates වලින් ආපු output දෙක අරගෙන input විදියට පාවිච්චි කරලා තියෙනවා තවත් logic gate එක. ඒතකොට combinational circuits වලදී මේක තමයි වෙන්නේ. මේ විදියට කරාම ළමයි අපිට different conditions වලදී කොයි විදිහටද වැඩ කරන්න ඕනේ කියලා හදා ගන්න පුළුවන් circuit එක. Right? For the input here, you can see here A, B are the inputs for this AND gate, and A input is used for this AND gate also, right? In addition to that one, C is used for this AND gate. මේ බලන්න මේ පළවෙනි AND gate එක ගත්තාම A B කියන දෙකක් තියෙනවා. ඊට පස්සේ මේ ඊළඟ AND gate එක ගත්තාම ඒකට C කියලා input එකක් තියෙනවා. ඒ වගේම මේ A කියන input එකම මෙතනින් මෙයාත් පාවිච්චි කරනවා. දැන් මෙහෙම එකක් වෙන්නත් පුළුවන්. දැන් මෙහෙම තිබ්බනම් let's say if you want you can draw this kind of one. If you want to use 4 different inputs, right, then AB. AB is for this one, CD for this AND gate, right? Then මෙතන වෙන්නේ මොකද්ද? මේකට එක input එකක්, මේකට තව input එකක්, මේක එකක්, මේක එකක්. එතකොට මේක 1 0, right? දෙන්න පුළුවන්. B එකෙත් 1 0, C එකෙත් 1 0, D එකටත් 1 0. දැන් මේ විදියට ඇන්දොත් එහෙනම් මොකද වෙන්නේ ළමයි? If you draw like this, right? When you provided some kind of a condition to the A, input A, the same condition, same states apply for one input of this AND gate. මේ බලන්න මෙහෙම තියෙන එකේ වෙන්නේ දැන් මෙතන ගත්තොත් මම ඇඳපු එකේ මෙතන A කියන එකට මොන condition එකක් දුන්නත් C කියන එකට ඒක අදාළ වෙන්නේ නැහැ. C කියන එකට එතනදි දෙන condition එක input එකට දෙන condition එක තමයි මේ gate එකේට C එක හරහා යන්නේ. හැබැයි මේ දීලා තියෙන diagram එකේ ඔයගොල්ලෝ බැලුවොත් එහෙම A කියන එකට එක දුන්නොත් එහෙම in a one stage, right? Let's say we are going to provide 1 to A. The same one goes to the input of this AND gate. අපි මේ AND gates නම් කරගමු. මේක 1, මේක 2 කියලා. හරි. දැන් මේ බලන්න මේ පළවෙනි AND gate එකේ එක input එකට අපි 1 දුන්නොත් එහෙම මේ දෙවෙනි AND gate එකේ input එකට ඒ වෙලාවම 1 තමයි යන්නේ. පළවෙනි AND gate එකට 0 කියලා දුන්නොත් එහෙම කොහෙද හරි, right? මේ 0ම තමයි මෙතනට ඇවිල්ලා apply වෙන්නේ. ඒ හින්දා තමයි අපි මේ වගේ draw කරන්නේ. මේක separate draw කරා නම් මෙතනට දෙන condition එක මොකක් වුණත් වැඩක් නැහැ. මෙතනට දෙන එකෙන් තමයි ඒක අදාළ වෙන්නේ ඒ වෙලාවේදී මේ AND gate එකට. But here B we are going to provide 1 or 0, right? But there's no relationship. Relationship with this input, right? That means the conditions or the states given to the input of B has no relationship with the conditions which are given to the input C of second AND gate. දැන් මෙතන C එකට කොයි වෙලේ බිඳුව දෙනවද කොයි වෙලේ 1 දෙනවද කියලා දන්නේ නැහැ. නමුත් මෙන්න මේ විදියට inputs දෙකක් combine කරාම මෙතනට 0 දුන්නොත් ඒ වෙලේම මේකටත් 0 apply වෙන්නේ. මෙතනට 1 දුන්නොත් ඒ වෙලේම මෙතනට 1 apply වෙන්නේ. Right. Then we will see the truth table for this combinational circuit. මේ තියෙන්නේ truth table එක, right? Inputs අපි දන්නවා A කියලා තියෙනවා, B කියලා තියෙනවා, C කියලා තියෙනවා, right? Inputs තුනක් එතකොට මෙතන තියෙනවා. Then there are 2 outputs. One is D, the other one is E. DE. Then these outputs from these AND gates are used as the input for this OR gate. ඊට පස්සේ මේ OR gate එකේ X එක තමයි output එක. එහෙනම් truth table එක ඔයගලන්ට පැහැදිලිව පේනවා, right? There are 3 inputs, then there are 2 outputs. This is the output for AND gate number 1, and number 1. This is the output for AND gate number 2, and these outputs are used as the input for the OR gate, and this is the output of OR gate. Right, then we are going to draw the truth table. There are 3 different types of inputs here, right? So that means how many combinations will be there? 3. Exponent is 2 to power 3 equals 2 times 2 times 2. 8 different combinations are there. So when we draw the truth table, right, we have to show all these combinations. එහෙනම් මෙතන ලියනකොට right අපි inputs 3ක් තියෙනවා. පළවෙනි input එක you know how to write 0 1 0 1 0 1 0 1 like this, right? Up to 8 numbers. Then next line we are going to write 0 0 1 1 0 0 1 1. Next one 0 0 0 0 1 1 1 1. This is the pattern you can write. Then because when you write in that pattern you can have all the different combinations. මේ pattern එකට ලියුවොත් ඔයගලන්ට කිසිම combination එකක් මගහැරෙන්නේ නැහැ. එතකොට ඔක්කොම combinations ටික තියෙනවා. හරි. එහෙනම් combinations 8ක් තියෙනවා. එයාටම දැන් මෙතන තියෙනවා. දැන් අපි බලන්න ඕනේ ළමයි D එකේ output එකට එන answer එක මොකක්ද කියලා. Here you know D is the output of AND gate 1, right? So input related to this number 1 AND gate are A and B. එහෙනම් A and B එකේ condition එක අනුව තමයි අපිට D එකේ output එක decide කරන්න වෙන්නේ. Right. Now this is a AND gate, right? You know the behavior of AND gate. That means only both A and B have the condition 1, output becomes 1. අනික් විදිහට කියනවා නම් both A and B are true, output becomes true. Otherwise it's false. Right. Then here I am going to fill the D column. එහෙනම් D එක කියන්නේ AND gate එකේ 1 එක හොඳට බලන්න. A එකයි B එකයි A and B are 0, definitely output is 0. Right? In here A B is 0, output is 0. In here A is 0, B is 1, but output is 0 because it's an AND gate. It's an AND gate. Then here A0, B1, because of AND gate it's 0. Right? Make it එහෙමයි. මේ එකක් 0 නම් 0. එකක් 0 නම් 0 බල බල ඉන්න දෙයක් නැහැ. And here A is 1, B is 1. So therefore D becomes 1, output becomes 1. Because the behavior of AND gate is, right, if both inputs are 1, you get 1 as the output. Then here this combination 1, A is 1, B is 1, and therefore D is 1. ඇයි අපි මේ C එක කිසිම අදාළත්වයක් නැහැ ළමයි. මොකද D කියලා කියන්නේ AND gate 1 එකේ output එක. Right? So therefore C එක අපිට අදාළ වෙන්නේ නැහැ. මේකේ output එක calculate කරනකොට calculate decide කරනකොට. Then right, now we are going to decide the output of E according to in the different kind of combinations. So for the output E, right, output E depends on the input of A. Here A and C. දැන් අපි බලමු E එක, right? A එකට relate වෙන්නේ මොකක්ද? A එකයි C එකයි. When the A is 0, C is 0, output of AND gate 2. That means E is 0, right? E becomes 1 only both A and C are true. Then we have to find that condition. මේක අපි fill කරනකොට එක එක බල බල යන්න ඕනේ. අපි බලමු A එකයි C එකයි දෙකම එක වෙන්නේ කොහෙද කියලා. මේ here in this row A is 1, C is 1, so therefore E is 1. And again here A is 1, C is 1, right? Then E is 1. For the other rows, right, we can fill with zeros, right? Now we know, now we have filled D column and the E column. Then now we have to fill this X. How we can fill the X? Let's see. Here, X. X is the output of OR gate. Inputs are D and E. Now we have derived the values of D and E, right? Based on this behavior of the OR gate, we can decide the output of X. OR gate එකේ behavior ගොල්ලන්ට මතකද ළමයි? OR gate එකේ behavior එක තමයි මේ inputs දෙකෙන් ඕනම එකක් එක වුණොත් හරි දෙකම එක වුණොත් හරි output එක එක. මේ දෙකම බිඳුව වුණොත් විතරයි output එක බිඳුව වෙන්නේ. එහෙනම් අපිට බලන්න පුළුවන්, right, මේක D is 0, E is 0, both are 0, then the output is 0. In here both are 0, output is 0, right? But when you see this one, D is 0 but E is 1, so the one input is 1, therefore the output is 1. In here D is 1, E is 0, so therefore output of OR gate is 1. Here both are 1, definitely the output is 1. ඇයි මෙතන මේ මේ OR gate එකේ output එක OR gate එකක් behave වෙන්නේ, ඔයගොල්ලෝ දන්නවා OR gate එකක් හැසිරෙන්නේ ඒකේ input වලින් ඕනම එකක් එක වුණොත් output එක එක වෙනවා. ඒ හින්දා අපිට පුළුවන් මේ line එකත් fill කරගන්න, right? So then it says, because there are 3 inputs to this circuit, 8 rows are required to describe all possible input combinations, right? It's okay, you know. This same circuit using Boolean algebra, sorry. If you use Boolean algebra, right, you can write like this. A, B, O, A, C. කොහොමද මේක ආවේ? Right. How you can write a Boolean algebra from this kind of a circuit. Right. First, you have to write the Boolean algebra for the output of D. Output of D is a output of an AND gate. What are the inputs? A and B. So then D equals, students, D equals A and B. How you represent the output of an AND gate? A dot B. It says we call it A and B, right? Then output of E. Output of this AND gate is E. Then the E equals E එක මොකක්ද එහෙනම් වෙන්නේ? E එකට බලපාන්නේ B එකයි, sorry, C එකයි A එකයි කියන input දෙක. එහෙනම් A and C, because this is AND gate, so we have to write in this manner, A and C. හරි. එහෙනම් මෙන්න අපි දන්නවා දැන් මේ output දෙක input වලින් represent කරාම. Now X කියලා කියන්නේ මොකක්ද මෙතන? X එක අපිට ලියන්න පුළුවන් ඕනනම් මේ විදිහට. D O E, right? D is the input, E is the input, the other input. This is a OR gate. You know how to write a OR gate. OR gate's output always equals to, right, D O E. Then now you know D and E from these initial inputs. Now we can write this one like this. X equal D is A and B. A and B. Then we can use brackets. Or this one E. Now you know E from their inputs. Its inputs A and C. එහෙනම් right අපි මේ විදිහට තමයි output එකක් ලියන්නේ. අපි එන්න ඕනේ ඉස්සෙල්ලම inputs පැත්තේ ඉඳලා. මුලින්ම inputs මොනවාද කියලා බලලා පළවෙනි output එක ලියා ගන්නවා. ඊට පස්සේ මෙතනත් inputs බලලා එතනින් එන output එක ලියා ගන්නවා. ඊට පස්සේ අන්තිමට තියෙන මේ output එකට inputs බලලා ඉවරලා ලියා ගන්නවා D1යි E1යි. ඊට පස්සේ D1යි E1යි අපි හොයාගෙන තියෙනවා කොහොමද basic inputs වලින් හැදෙන්නේ කියලා. ඊට පස්සේ අපි ඒ ටිකෙන් ඒක ලියා ගන්න. Right. So this is another example. Right? This is another example. Just see this one. This AND gate has two inputs. One is A. The other one is, other input is the output of this OR gate. Right? So let's say, අපි බලමු මෙතනට අපි දාමු ළමයි x කියලා. මේ input එක x කියමුකෝ. හරි. මේ input එක x කියලා අපි consider කරමුකෝ. එතකොට මේ AND gate එකට තියෙනවා a1යි x1යි input දෙකක්. හැබැයි මේ x1 කියලා කියන්නේ මොකක්ද? මේකෙන් එන output එක. Right? ඒ විදිහට consider කරන්න පුළුවන්. එතකොට x equals b plus c. ඇයි මේ output එක තමයි x කියලා කියන්නේ. එහෙම නැත්නම් ඒ ඉස්සෙල්ල විදිහට හිතුවොත් අපි ඒව මුකුත් හිතන්නේ නැතුව මේ විදිහටම බලාගෙන යමු. We will see. Right. So it has two inputs. One is A. The other one is output from this one. So first of all, we have to derive the output from this one. So input for this OR gate is B, C. These are the inputs. How you can write the output of OR gate? Right. Output always equals, we write like this, B plus C. That means B or C. OR gate එකක්නේ. හරි. මෙන්න මේක තමයි මේකේ ආපු output එක. දැන් මේකේ input එකක් විදිහට use වෙනවා මේ AND gate එකට. ඒකත් use වෙනවා. එහෙනම් AND gate එකේ output එකක් අපි කොහොමද ලියන්නේ ළමයි? ඔයගොල්ලෝ දන්නවා AND gate එක output එකක් ලියන්නේ මේ විදිහට. AND gate එකක් තිබ්බොත් එහෙම A B කියලා inputs are A B, output is C. C equals A and B, like this. In this example, right, we are also going to write like this. The output equals A and one input is the A. The other input is B plus C. B plus C means B or C. Through the OR gate, it came. We call it B or C. එහෙනම් මේක තමයි final output එක. Right. If you are going to write a truth table, you can see how many inputs are there. 1, 2, 3. So therefore, there will be how many combinations? 2 to power 3. Right? 3 inputs තියෙනවනේ. එහෙනම් 8 different type of combinations will be there. So now you have to write a truth table for each different kind of combinations. You can write C input, right? 0 1 0 1 0 1 0 1. Then for B input 0 0 1 1 0 0 1 1. The next one 0 0 0 0 1 1 1 1. All combinations are there. Then you have to first decide the output of here, right? B plus C, B or C. So this column shows the output B or C based on these two inputs B and C. Because this is OR gate, you know OR gate, right? output becomes true if one of inputs is true or both are true. හරි. දෙකෙන් එකක් true වුණත් එහෙම නැත්නම් දෙකම true වුණත් output එක true වෙනවා or gate එකක. එහෙනම් බලමු එතන වෙලා තියෙන බිඳුව ඇවිදින දෙකම false නම් right output එක false. දෙකෙන් එකක් right මෙතන C එක true වෙලා තියෙනවා එහෙනම් output එක true. මෙතන B එක true වෙලා තියෙනවා output එක true. මෙතන දෙකම true හින්දා output එක true. මෙතන ආයිසරයක් දෙකම 0 හින්දා output එක 0 right here according to conditions right in output is 1 right. Now the output of OR gate is ready. Now we have to consider the output of this AND gate. One input for this AND gate is A. එක input එකක් A. ඊළඟ input එක තමයි B or C කියන condition එක. මෙන්න මේක. එහෙනම් අපි මේ AND gate එකේ output එක decide කරනකොට what we are going to use this column B O C and this one A right. Then this is the AND gate. What is the logic behind the AND gate? Output becomes 1 only both inputs are true. AND gate එකේ condition එක එක තමයි. එහෙනම් අපි එක කියලා දාන්න පුළුවන් මෙන්න මෙතනින් එන input එකත් එක වෙන සහ මේ input එකත් එක වෙන අවස්ථාවලට විතර. එහෙනම් අපි බලමු මේ දෙකම එක වෙන්නේ කොයිද කියලා. A එක එක මෙතන A0 here B plus 0 then we can't use that one. A is 0 B plus 1 B or Z is 1 right we can't use that one right. But here A is 1 BOC condition is 1 so therefore output of this AND gate becomes 1. In here also both conditions are 1 output is 1. Here also both conditions are 1 so the output is 1 right. Output has written in Boolean algebra A and BOC here A and BOC. එහෙනම් මේ විදිහට තමයි ඔයගොල්ලෝ truth table එකක් create කරගන්නේ. Right, then it's very clear. I am going to then ask a question, then after that we can finish the lesson. Right, tell me this one. AND gate is there, right? A, this is B. Another AND gate is there. C. Another AND gate is there, right? X is the output, right? Here. Output from this one. This is the first AND gate. This is the second AND gate. Output from this one is J. Output of this one is K, right? First tell me students, what is the output? How you can write the output J from the inputs of this AND gate? කවුරු හරි type කරන්න. Right, thank you very much Piumal for participating. Right, that's true. J equals A and B because this is an AND gate, right? So A and B. Right, now tell me the expression for the K. Boolean expression for the output. Output is K, output of this second AND gate. What are the inputs? B and C. Yes. Thank you, Fernando and Nisma. B, C. Right. Here, B and C. Because these are the inputs. Right. Now tell me what is the final output. How can you write the Boolean expression of this final output X? Right. I have got the answer from Nisma. And I have got the answer from Pumal. Pumal's answer, actually, it's not correct. Please just try again, Pumal. Right. So the answer is this one. X you can write like this. Either first one you can write if you want J. මේක AND gate එකක්නේ. J and K. ඒ විදිහට ලියන්නත් පුළුවන්. Different color එකක් use කරමු. X equal J and K. But this is not the answer I expect, right? I need a most simplified answer. So J means A and B. A and B, right? So we use bracket then, because bracket shows this is an output of one logic gate, right? එක logic gate එක output එකක් කියලා ආපු output එකක් කියන මේ brackets වලින් අපිට වෙන් කරගන්න පුළුවන්. මේ එකකින් ආපු output එක. එතකොට මේක තමයි මේ AND gate එකේ input එකක් විදිහට use කරන්නේ, right? Then next one, because this is AND gate, then again we have to put AND mark, right? That's a dot. And what's the next other input of this AND gate? That's K. K means B and C. B dot C. Right. So then you have to write in this way. This shows, right? මේකෙන් පෙන්නනවා J කියන, right? Input එක මේ AND gate එකට J කියන input එක හැදිලා තියෙන්නේ මේ AB කියන එකෙන් A and B කියන එක, right? මේ පෙන්නන්නේ J. ඊට පස්සේ J and K කියන එක තමයි මේ පෙන්නන්නේ simplified version එකේ. B and C වලින් කියන්නේ K එක. Right? එහෙනම් එතකොට ඔයගොල්ලෝ මේවා brackets හරියට use කරන්න ඕනේ ළමයි. Because in one bracket it shows one output of a particular logic gate, right? Then see another one, another example. This one. Please be careful, right? Right. Output is X. Right. Now, what's the output? This is an AND gate. This is an OR gate. This is another AND gate. Right. We will see the answer. First, I want to find the output of this AND gate. Inputs are A and B. So the output of this AND gate is A and B. Right. Now I want to find the output of this OR gate. Inputs are B and C. Because of this OR gate, we can write B, O, C. Right. Then these are used. The output from these gates are used as the inputs for this AND gate. Then answer for the X is, right, one input is A and B. Because this is an AND gate, we have to use AND. Another input is B and C. B, sorry, B or C. So this is the answer. දැන් ඕගලන්ට හදිස්සියේ මෙතන මෙහෙම තිබ්බනම් ළමයි අර වගේ මේ output එක කියලා කියන්නේ J, මේ output එක කියලා කියන්නේ K. ඔහොම තිබ්බනම් සමහරක් අයට ලේසි, right? මොකද ඉස්සෙල්ලා J එක හදා ගන්නවා. J එක කියලා කියන්නේ නමුත් ඒ විදිහටම දෙන්නේ නැහැ exam එකේදී. You will not get in the same way, right? Here the J, then the J equals A and B because of this is AND gate. Here the K output is K, right? K equals B or C because this is the OR gate. Then you can write, first you can write X output of this AND gate in J and K. Because of this is AND gate, we can write J and K. Then you can simplify, right? J equals A and B, and from here K equals B or C. ඔහොම. ඉතින් හැමතිස්සෙම මේ තැන් වලට මෙහෙම දෙන්නේ නැහැ. Inputs, sorry, outputs නම් කරලා දෙන්නේ නැහැ. Right? So then you have to derive the final Boolean algebra. Right? Then I am going to do another two examples. One is this one. Right. Try to do this one. Okay, then we will see the answer. Right, good. Fernando's one is also correct. Now let's derive the answer for here. This is an OR gate. Inputs are X and Y. So we can get the output as X or Y. Right. This is one. This is an AND gate. Inputs are X and Z. Here the X and Z. So because of this AND gate, we can write X and Z. We use brackets because we are going to use these outputs as the input of this logic gate. Then this is an OR gate, right? So now we have to write, then this is a one input X or Y, or because this is OR gate, and the other input for this OR gate is this one, X and Z, right? Then here in this circuit there is a NOT gate. What is the purpose of NOT gate? The inverse, right? It inverts the input. You get the inverse of the input as the output. So NOT gate, can you remember? If you give X, it will give X bar. If you give A, it will give A bar. If you give B, it will give B bar, right? So therefore, right, I am going to write the answer. like this: X, O, Y, O, X, and Z bar, right? So that's the answer, right? Okay, then that's good. My last question is this one. Right, try this one. Okay, then we will try getting the answer, right? Output to here, right? This is an OR gate. Inputs are A and B. Output is A, O, B, right? Here, this is an AND gate. Inputs are C and D. Output is C and D. There is a NOT gate. So then what would happen, right? We will get the opposite side, other side of this AOB. Then you can write it like this: AOB bar. Sometimes students, the same thing, right? You can write like this: AOB bar, like this. But when you type in the chat, you can write represent in this way. But in the exam, right, you have to draw the bar like this. Okay, then we will see the final answer, right? These are the input for this OR gate. Then the final answer will be, this is the OR gate, then here A, O, B bar. This one comes from here, right? I can use again square bracket. Then this is a OR gate, therefore O mark is there. C and D. C and D, right? So this is the answer for this question, right? Okay, then that's the end of the lesson. Now you know, right? Now you can recognize any kind of logic gate, right? You know the basic logic gates types, and you know the truth table or the behavior of these logic gates, and you know how to get the final output of this kind of combinational circuits, right? Okay, then that's the end of this lesson, and now, right, your syllabus is fully completed.